Previously, you've looked at U-substitution. What I'd like to do today is remind us to be careful with limits when we're integrating using U-substitution. So for example, say we wanted the integral of tangent x times secant squared x dx from 0 to pi over 4. So remember, the way you notice that u sub should be used here is the derivative of tangent is secant squared. So you have an integrand there that contains a function and that function's derivative. So u substitution would work here. So that function, tangent, is our u. And the differential, du, is secant squared x dx. Fairly straightforward at this point, but I want to emphasize something. Remember, this dx here is telling us what the variable of integration is. Implied in that is that this number here is an x. This number here is an x. Even though we don't write that, that symbol tells us that those numbers are values of x. So when I rewrite this integral, tangent x is u, secant squared x dx is du. When I write these limits, that symbol du is telling me that the numbers that are written here are values of u. So I don't simply want to copy 0 and pi over 4 over there. If I do, I'm writing something that's incorrect, because it's not the integral of u from 0 to pi over 4. It's the integral from x from 0 to pi over 4. So I want to switch these x's so that when they're over here, they're u's. Well, there's your conversion formula, right? The u substitution, you're defining a new variable in terms of the old. So it tells you how to convert any value of x into a value of u. So when x is 0, this is tangent of 0. When this is pi over 4, this is tangent of pi over 4. Now, those are common angles, so we know the value of tangent there. If these aren't common angles, then that's an irrational number, and we should probably just leave it as tangent of whatever that angle is. But we know these values, so let's simplify. Tangent of 0 is 0. Tangent of pi over 4 is 1. And now we're ready for our antiderivative. So what I want to see from you is when you make a switch to a new variable, I want to see these limits now in terms of the new variable. There's a couple of advantages to that. One is, in more complicated problems, you might change variables several times. And if you don't update the limits, you're going to have to backtrack all the way back to the original variable at the end. Also, with trig functions, as we'll see later on, your new limits might go from 0 to 0, in which case you're done, or 1 to 1. These limits might end up being the same because of the periodicity of trig functions, in which case you don't even have to find the antiderivative. So always update these limits. Every time there's a change in variable, change the limits. Then to just finish this off, we take our antiderivative. 1 into that is a half. 0 into that is 0. So our integral is a half. Next time, what I want to look at is a way of avoiding a lot of the details of u substitution when the u is simply a linear expression. We'll look at that next time.